All right, we have a nonlinear, not by much, but we have a nonlinear set of data here. You could actually do least squares regression, and you could fit a line in the least squares regression, like so. Hold on a second. Let's go with blue. And maybe have it go something like this. Okay? You could do that. But it looks like to me it's nonlinear. If you was to take these points and put them together, then you would have a nonlinear term or nonlinear line. If I could draw with this thing, 1, 2, 3, 4, 5, 6. So besides me messing up the dots, it looks like a very wide parabola that if you was to extend it, looks like it could fall right at what? 0. So what do you do? Do you do the linear or do you do the non-linear? Well, since we did a non-linear Friday, chances are we need to do a non-linear here. Now the good thing about it is there's a bad thing and a good thing. The bad thing is they don't give you a 0y term. They give you a 0x term. I mean, they don't give you a 0x term either. So therefore you can't zero out any terms and get y is equal or c is equal to anything. So that's not going to help you. Good news is you got your handy dandy calculator. So go ahead and pull up your handy dandy calculator. And now that you know that you have a nonlinear, go ahead and punch your numbers into stat, edit, and 2006.
Help.
What? Oh,
That was somebody in the office.
Oh, okay. Sound like somebody needed help. 2006.
Someone said help.
2007. 2008, 2009, 2010, 2011, and 2012. .045, 0.114, 0.273, 0.409, 0.545, 0.791,
Next.
and 1.023.
Next. That. Like finish your wafer machine.
Can y'all like close that door?
Thank you.
Easily Campus, please. Thank you. Alright, so there's that. And now we just hit the handy dandy stat, calculate. And if you wanted to do a linear regression, you would hit linear regression. That's a straight line. But since we're in a non-linear section, you might want to hit quadratic regression. and second L1, comma, L2. It should read it. And there you go. Now I want you to find the vertex and describe what this function's doing. Now, look at those. We got decimals, so now you need the quadratic formula, because that's what the quadratic formula is for. Quadratic formula is for you to use whenever you have a cluster like this. So plug it in, see what you get. I'll be writing it down over here. Okay.
Priority 1 message coming in on secured channel.
Incoming message.
Make sure that ain't anybody Skyping in. Okay, hold on, let me see if she's... Hold on just a second. See, I need to move this over here. And then move this over here. Okay, so we've got these points. And we know what the graph looks like. The graph looks like these blue dots right here. So we know it's nonlinear. And we know, since using quadratic regression, after we plugged it in, we got y is equal to 0.015 x squared minus 59.63 minus 59.63x plus 59,733.95. Now, if you notice, that y-intercept is huge, but it doesn't look like that on the graph. And I think the reason that is because 2006 and 2012, those are not mathematical years. So what we might want to do is we might want to change our format and go over here to Stat and Edit, and maybe change these years since 2000. So this would be 6, this would be 7, 8, 9, 10, 11, 12. And that might make the answer a little bit more, what's the word I'm trying to say? Normal. Quadratic regression, L1, comma, L2. Enter. That looks a little bit better. All right. The reason I wrote this down and I said, "Whoa, wait a minute," is because look back at your graph. That's why you draw a graph. You draw a graph because you want to see what's going on, and you can't see what's going on if you don't draw a graph. So here's, let's see, I think that's about right there, isn't it? All right, there's your points. Now, some of y'all look, this red line is heading towards 0. So when I saw the 59,733, I knew that was wrong. So then I went back and said to myself, well, 2006 is not really a mathematical number. 2006 is a year. It's more of a noun. Okay? It's a year. So change that to years since 2000, and then it becomes a mathematical number. And therefore, it won't throw your y-intercept off. All right? So, instead of the 59,733, which we know cannot be possible since the red line is crossing right here at 0, 0, we know that that's not possible, so we cross that out, and we say y is equal to 0.015 x squared minus 0.11 x plus 0.137. Now, is there anything we can do to this to make it to where we can do completing the square? Yes or no? Because we don't want to have to use, we don't want to have to use the quadratic formula, because then we have to depend on what? Calculator. So is there anything we can do to this quadratic to where we can use completing the square? Anybody want to take a stab at it? What do we do with fractions and decimals whenever we don't want to deal with them? Erase them?
You bring them out.
Take them out. In other words, multiply by 1,000. But if we did that, then we get 1,000y, so that wouldn't help us. There's not really anything you can do. All right? So
what is your professional opinion?
We're going to have to use the quadratic formula, or try to use completing the square, but even I wouldn't suggest using completing the square on this one, because that's like using a flathead screwdriver on a Phillips head screw. All right? There's reasons we have the quadratic formula and the reasons we have completing the square. Now in this case, let's do x is equal to negative b plus or minus the square root of b squared minus 4ac all over what?
2a.
2a. Now remember, the vertex is equal to what? With the quadratic formula, you have to do more work. The vertex is equal to negative b over 2a, and then f of negative b over 2a. So once you get negative b over 2a, you have to plug negative b over 2a into the actual formula to get the y of the vertex. So x is equal to negative parentheses plus or negative plus or minus parentheses squared minus 4 times parentheses over 2 times parentheses. And b is negative what? 0.11. And a is 0.015 and 0.137 and 0.015. X is equal to 0.11 plus or minus 0.11 squared be a minus 4 times 0.1015 times 0.137 over, well, 2 times, that'd be 0.030, would it not? 0.030. And the only thing I did right there is clean it up a little bit. Now you can do all your, so the people that spins calculators on their fingers like a basketball in high school, go to it. Knock yourself out. Okay? Take your handy dandy calculator and 0.11 squared I'm not one of those people that take a calculator with me everywhere I go. All right, minus parentheses 4 times 0.015 times 0.137. Y'all check me. And for the radicand, let's see, equals, I got 0.00388. So that equals 0.11 plus or minus square root of 0.00388. Somebody check it. 0.00388 over 0.030. And now raise that to the 0.5 power. And that's 0.062. So that's 0.11 plus or minus 0.062 over 0.030. What's 11 cent plus 6 cent? 17 cent divided by 3 is going to be 5 2/3, 5.67, something like that. So 1x intercept is 5.67. The other one, 11 cent minus 6 cent is 5 cent. 5 cents over 3 is going to be 1 2/3. So you got negative and a positive. So it's crossing those 2 points. Vertex, negative 0.11 over 2 times 0.105 or 0.15. And that's going to be a negative because the negative's right there. And then comma. And then whatever that number is, you're going to plug into. So take your 0.11. And all this should be second nature to you from the way they drilled this in your head in high school. The quadratic formula, quadratic formula, quadratic formula, quadratic formula. Negative b over 2a is negative 0.11 divided by 0.015 times 2. Let me put it brackets. Second. The reason I'm doing this is to show you something. 2 times 0.015 close parentheses. Okay, it didn't like that. Must have
You put 4 or 5.
Okay, thank you. No, I put a. There we go. And change that to 0.15. There we go. Had a brace in there instead of a parenthesis. I got 3.66. So now you get to take 3.66 and you get to plug it into this right here. So 3.66 raised to the second power times 0.015 or 0.015 equals minus 0.11 times, let me put that in parentheses. Sorry. Let's see, second insert, and that's going to be 0.11, and then go, sorry, times x, that'd be 3.66 times 3.66, close parentheses, plus 0.137. I got negative 0.06. Negative 0.06. So that's your vertex. That's your lowest point. That's your x-intercepts. And this is your y-intercept. So you know that function is coming down something like this. All right, that's what you have. And then we also know that it's crossing at these two intercepts, and it's also crossing at 0.137, which would be right in there. The vertex is 3.66 and negative 0.6. So 3.66 and negative 0.6 is down here somewhere. So it's, I don't have it drawn correctly, but anyway, it's doing something like that. Okay? Now, the point of me showing you all this is in this context of this book, all right? One, you have to know graphing in and out. Two, you have to know linear versus nonlinear in and out. And three, you have to know quadratics in and out. Okay? If you choose not to learn those three things, then you might as well change majors from business. All right? Because you're dealing, 90% of the time, you're going to be dealing with something in this quadrant. And if you don't know, if you're ignorant to those three things, then you're either going to get fired or you're not going to make it past college, because you're going to continue on this path of economics, you're going to continue on this path of calculus, you're going to continue on this path with whatever you're studying in marketing, business, or management. You're going to be studying that first quadrant. And whether you like it or not, those three things you have to know. Just like, what do I do in case of this? Well, that y-intercept looks very big. Something's not right, because my graph tells me that I'm heading toward what? I'm heading toward the origin. So something must be wrong here. Well, wait a minute. 2009 is not mathematical. Okay? But 9 is, because it's 9 years from 2000. And you have to think about that. I can't put it in any other context versus, I'll tell you what, how about your Social Security number? Is it mathematical?
They're numbers.
No, it is not mathematical. Why do you have a Social Security number?
So the government can identify me.
It's an identification, okay? 2009 is an identification, whereas 9 is more like an age. It's something mathematical. It's something that you can actually figure, all right? And that's the context that you have to learn with these things. What else? Okay, now I've got a quadratic with a bunch of what?
Decimals.
Decimals. What do? I can't use completing the square. Now is when you use the quadratic formula. Now, how many times are you going to see this on a test in a math class? Not very many times. You're not going to see this too many times on a math test. But will you see this in the real world? Yes. So you need to be able to go, okay, I can't do completing the square because that'll be a cluster. So I need to revert back to the quadratic formula. And here is where you really need to learn how to use what? Your calculator. Or your spreadsheet, or whatever the case may be. You can actually do a spreadsheet program for this where you type in just 2 or 3 numbers and you get the answer. All right? For some of you like me that like to play on Excel and make it do things like that. All right? Then what? Then what do you find? You find your x-intercepts, your y-intercept, and your vertex, and then you actually say, okay, well that thing is going to cross at 0.037, so that means 0 and 0.137 is where I stop making widgets. In other words, at 0, I'm putting in a cost of, if I make 0 widgets, I'm putting in a cost of 14 cents or whatever the case may be. That is a y-intercept. Y and x-intercepts are very important in marketing and business. Very important. Okay, so that's basically what we're doing in 5.4 or 3.4. So the first thing you need to be able to do in 3.4 is find an equation of a nonlinear by hand. Okay, now if I give you one by hand, then that means there has to be a 0 in there somewhere. All right, now the 0 the other day was 0, 5 or something like that, and I think we had a 4 and 13 and a 5 and 25 or something like that. Okay, now this is the key right here. When you're told to find an equation and you have something like this, then you can do it by hand. Because what does that x do to most of your terms in the quadratic equation? Cancels them out and you're left with 5 is equal to c, or 4 is equal to c. So this one is solvable because you have a 0 term that eliminates stuff. Versus find an equation not given 0 terms. And if you're not given 0 terms, you have to rely on your calculator and use quadratic regression. Now also you need to put under there linear regression, because sometimes you may be asked to find the information about a linear line, and that would be linear regression. Okay? And the quadratic regression gives you ax squared plus bx plus c. It gives you a, b, and c, and then you plug it in. The linear regression, I think I went over this with you, gives you m and what? Y equals mx plus what? B. It gives you m and b. Now see, these two things right here fall in right here. Okay? So I would highly suggest that when you're doing 3.4 homework to pay attention to these type problems. Okay? Now, of course, there's the graph, and it goes through and tells you that you need to change since 2000, and it draws some kind of a regression line curve in there. And then they ask you to reach 3 billion, or 3 billion intersecting y is equal to 3. Now, the way that you do that is you would just go in your calculator and type in y is equal to 3 after you do a stat plot and see where it crosses. That's not a big deal. Let's see if this, here's another example. Let's type these in. Go ahead and type these in. Type them in your calculator. Then graph it, because you need to look and see what kind of a graph you're talking about. and then what to do with that graph. Did y'all not bring calculators? Y'all don't have your calculators?
Forgot mine.
Y'all.
They suck.
I know.
Oh.
You want to use mine?
Yeah, sure.
I can't move.
You gotta.
I'm wet. My legs are soaking wet.
Oh, bless
They're
your
cold.
heart.
I know, I'm cold now.
Oh,
I'm gonna get
bless your
pneumonia.
heart. 8,
Okay.
Pneumonia through your legs.
I'm gonna get pneumonia through my legs.
10,
The
11.
stairs are literally waterfalls right now.
Yeah,
Well-
that's crazy.
Like legit waterfalls. Like
13.
there's cascading noise coming down, and they're like.
Well,
coming
see, at
off the
Anderson
sky.
campus, we don't have stairs, so
You see, Pendleton, all we have is stairs.
we got Cardiac Hill. See, that's another reason for you to it's only 16 minutes to the Anderson campus from the Pendleton campus. One shot. Then you don't have to put up with all the crap. 13, 14, 15, 16, 17, 18, 19, and 20. Now we could see into the future. $7.8, 9.5. See if I can do this. 9.553, 11.665, 14.568, 17.831, 21.393, 25.270, 29.503, 34.158, 39.330, 45.15, 1.5, and 59.453.
That's $2. That's a grande iced coffee from Starbucks.
What? All right, stat. Go to stat plot.
Yeah.
Turn the plot on. Type in on and graph. And do zoom. What was it? 9. 9. Okay, so you would be crazy to say this is linear because it's not. It's non-linear. So now you hit stat, calculate, and then go down to what? Quadratic regression, second, L1, comma, second, L2. Enter. And write that information down. Now you have A, B, and C, so now you have a quadratic equation. Now, that's what they did here. They graphed it. And, okay, I have a nonlinear. So, therefore, it's a quadratic. They get 0.231 minus 0.246 plus 11.13. And then if you wanted to, you could actually go through and say y is equal and type in that quadratic and it'd go right through your points. Okay? If you wanted to do that. Use the model to predict the revenue in 2019. So do that. What would you do? Well, take our handy dandy white paper, and y is equal to 0.23 x squared minus 2.25 x plus 11.13. And x is equal to what? 19. So plug and chug. 0.23 times 19 squared minus 2.25 times 19 plus 11.13. Calculate that out and see what you get. That means y'all have to take a calculator and you have to punch the buttons. Y'all didn't even bring a calculator.
I've got mine right here.
2 people at Pendleton campus brought a calculator.
Happened to.
1, 2, 3.
Okay.
4.
Okay, well that's good because
5.
usually like y'all are on the silent drill team for calculators, and like everybody brings it and it's all in synchronization. So I guess it's a good thing.
Yet?
What?
Have you used Desmos yet? That thing I told you about?
No.
You need to look at it. It's really, really convenient.
I went on. This is not changing the subject, but I had a student suggest that I look at a show on Netflix last night. One of my classes we were talking about it, and they said you need to go on Netflix and watch Strange Things.
Stranger Things.
Yeah, Stranger Things. Oh my gosh,
It's not a good show.
Me and my son was up till like 3 o'clock in the morning watching those things. We watched the whole first season. I'm like,
The new one
oh my
comes out in like
gosh.
3 days, right?
Yeah, the new one comes out. There's a countdown.
So did you like it, Mr. Huber?
Oh gosh, it was good. My son even liked it. He don't like stuff like that, but he even liked it.
11.
The next season comes out in a couple of days.
I know. Okay, what'd y'all get?
Rip.
What does that mean?
Come on.
That's my old card. That probably doesn't work. See, that was
Well, 19 squared.
That was a good try. I know, I was waiting for that.
Anybody get an answer yet?
No,
Might
I
as well
didn't.
do it. Oh, you go ahead and do it. Here. 23 minus parentheses 2.25 times 19 equals plus 11.13. Okay, did y'all get 51.41?
Yes.
So 50 points. So in 2019, this company is going to do 51.41 whatevers of whatever. In 2019. In 2019, the blank will be 51.4 blank. And like I said, this is the kind of stuff you're going to have to be fluent in. Just like if you were in Spanish 3, you should be able to carry on a conversation between you and somebody from whoever speaks Spanish. I'm not going to say it because if I say Mexican, somebody will get offended. So if I say Spanish, somebody will get offended. So if you're in Spanish 3 and you're having to do a final exam, and your final exam is speaking fluently to somebody from somewhere that speaks Spanish, all right, then this is what you need to be doing in this class and in calculus to understand what you're going to be doing in economics and business and marketing. Capiche?
Yes, sir.
Okay, just to look at a few more things that let's see what else they And let's see, what did they get? I done lost it. Well, all right, did they get 51.96? Okay, I'm a little bit off. Rounding, I think they rounded, I rounded to 2 decimal places. I think they went on to 3 or 4 decimal places.
Breakfast doesn't start, lunch doesn't start for another 40 minutes.
Yeah, but I have to go to work at 11:30.
Oh.
Okay, that's just a couple more examples. So I need y'all to work on the 3.1, 3.2, and 3.4 homework and start
Yes,
sending in homework questions. We'll go over Wednesday homework questions from those 3 sections, okay? See y'all Wednesday. Y'all be careful. Please be careful in this rain. You know, we're in South Carolina. People can't travel and stuff like this. So,
Get this whole haul out.